Yeah. So we have added additionally two loopback interface to understand MED. On R1, I have these two networks, and I am advertising this under BGP network, mask, network, mask, and as a result, I'll be able to ping from R. Okay, let me on this router also. Router 7. For testing, I want to ping from router 7. So I want to see which route it takes. Let us say we have a policy that all traffic that is coming to 111 should come like this. All the other traffics like 111, and 11 should come like this. So this is our aim. You understand?
Mm-hmm.
So if someone is reaching 111, they are not allowed to come from R5. They should come from R4. See, so far we were focusing on traffic going out, leaving the autonomous system, Now with this MED, we can we can tune it to choose the path for inside traffic from out to in. MED is for out to in. The other attributes that we have configured is for
In to out.
in to out. Let's check that. As of now, if I trace route from router 7, yeah, understand. Trace 111.111.111 source 78.78.78.78. You can see it goes to 4 and then goes to 2. We are okay with this, but for 11, we want some special path, meaning we have a policy. The policy is to see even this goes via router 4. We don't care whether it is going via router 4, but when it received on router 2, we want it to be received. We want it to be received from router 5. We want it to be received from router 5. How do we achieve this? Are we ready for that? Shall we do? Did you understand
Yes,
the
I am ready.
scenario? Okay.
Yes, I do.
So here we got 3 networks. I'm going to do on router 2 verification show IP BGP, and I can see here 78 and 87 is coming from router 4. But we also want this to be given to us by router 5. Why it is not learning from 5? Let's go to 5. 5
Wait, I have a
also,
question.
yeah.
Go back. Go back where I can see router 1 routing table. No, router 2, sorry. Router 2 routing table. Why is that 1.1.1 is not valid and best?
You tell me. Try to answer this. You know this. What is the meaning of that small r?
It means that it knows root failure.
Very good.
It knows it from another routing protocol.
Correct. That is why it is not considered. You can also type this command to verify that. Show IPBGP rib failure. It says there is some other source with better administrative distance. BGP's
Okay.
is higher. Okay, now coming back to our MAD scenario, router 2 should be learning it from both 4 and 5. Only then I can say for 111 entries from router 2, for 1111 and 11 entries from router 5. But right now we don't see a route coming from those 78 and 87. We don't see route coming from router 5. Only then, I'll be able to test MAD. So first, let us fix this. I should be learning like I'm learning from router 4. I also should be learning it from router 5. These two networks, because we are also connected to router 5. Show IP BGP summary. You see, sorry. Show IP BGP. We are forming neighbor with 2 and 4 here, which means the
Yes.
router 5 is supposed to give routes to router 2. Show IP BGP here on router 5. You see, we are learning this from router 7, but 5 do not know how to ping this. So unable to use this. What is the solution?
Maybe you could use next observe.
From where I need to give to which address I should say next stop self and which router I need to do it.
From router 5.
No. I should go to router 4 and say to router 5 next stop self. Is it correct or not? Are you
Yes,
confused?
you're correct.
Okay. Router BGP 20. Neighbor is 10.45.0.5. Next hop self. Likewise, these networks 11, 11, 11 also. No, that's not needed. Let us go now. Clear, clear IPBGP star soft. Let's go and check it on R5. Show IPBGP. Now you see router 5 is using the route given by router 4.
Yep.
And router 5 is learning 111 from both IBGP, which is router 4, and EBGP. It prefers EBGP. You remember, after MED, there is an attribute. EBGP is preferred over IBGP.
IBGP.
Okay, so that attribute is also over now. Router 1 is advertising 111. And router 5 is learning from both IBGP, which is router 4, and EBGP, this is EBGP address, which is router 2. It prefers EBGP. Yep. Now,
Yep.
what is next? Next is, I want to go and see router 4's BGP table, show IP BGP. What I see here is this 111 is advertised to router 4 by router 5 and by
Router
router
2.
2. It prefers router 2. That the reason maybe router 4 do not know how to ping this address, router 5's address. Yeah. So let us go and do next up self on router 5 also. Router BGP 20 neighbor 10.45.0.4 next up self. Clear. Now let us go and verify router 4. It is receiving from both router 5 as well as router 2. It prefers, again, it prefers eBGP over IBGP. Same reason. Okay.
Yes.
Now, this is the right time to go and test MAD. Now on R2, when you see the 78 is coming from both 5 as well as 4. So when packet comes from 78, it is received from router 4 and that is the best exit.
Mhm.
So when I trace route, where is router 7? When I trace route as usual, it is going to go via router 4, 4 to 1. Even for 111, it is taking same 4 to 1. We don't want this. For 111, we are okay with this, but for 11, we want it to be via router 5. If someone is pinging from outside, autonomous system 10 says only for 111 they are allowed to come from router 4. For other networks, they should come from router 5. So what I'm going to do, I'm going to write a access list on router 2. On router 2, access list, access
10.
list 10. Okay, 10. So we might have used this, when we did the local preference. I don't want to use
Mm.
10. Access list, let us say 55. Permit host 11.11.11.11. Access list 55. Sorry, say 55. 1.1.1.1. The reason why I'm matching this is this too is what I do not like to receive from router 4. If someone is coming, I do not want the packet destined to this addresses to come from router 4. MAD smaller is preferred. Okay, MAD smaller is preferred. You know what is the default MAD value?
I don't remember.
0. You see,
0.
show IP BGP. MAD is 0.
Okay.
And router 4, you go and see MAD is 0. Coming from router 5, MAD is 0.
Why some of them doesn't have any MED?
Come again?
Some of the routes, go back to number 2, let me see something. See, some of those routes doesn't have any MED.
If there is no MAD, which means they're all coming from eBGP neighbor.
Okay.
You see, this is IBGP. That's why you have MAD and local preference.
Okay.
Now let's go and check the same thing on router 4. You see, this is IBGP. You agree?
Yes.
Same.
Wait. Which one is IBGP? The one that one at one?
No, no. For 1.1.1.1, 10.45.05 is IBGP,
Yes.
whereas 10.24.02 is EBGP.
Wait. Yes.
That's why you don't see MAD or local
Mm-hmm.
preference.
Okay, preference. Okay.
Now, MAD, if there is no MAD, then also it is 0 only. Now, what I'm going to do is MAD bigger is bad, okay? MAD
Mm-hmm.
bigger
Bigger
is
is bad.
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 In another word, smaller is preferred.
Yes.
Now, this is 0. Let it be there. I'm going to give a big number here so that this will not be preferred. You understood?
Yes.
Okay. So I'll go to router 2 and say route map for MAD, match access list, match IP address
Match I.
55, set metric. I'm going to say 55. And for the rest, I don't want to set anything. Now I'll go under router BGP 10. Tell me what I'm planning to do. Can you guess what I'm trying to do to achieve what we learned? What I'm trying to do?
Neighbor.
Mhm.
Okay, the neighbor towards 5.
Ah, 10.25.0.5 route map for MAD. Okay, tell me what is
In.
next? No. Listen, those two networks in the access list. Are you receiving from router 5 or are giving
It's send it to router 5. It's sending them.
out, right?
Yes.
Okay. Clear IPBGP stars. Now let us go back to router 4. Router 4 says for 111 I will go via router 2.
Mm-hmm.
For 111 I can go via router 2, but for 111 and 222 it says I'm going via
It's
router.
still going.
Let's check it on here. Sure, I can check. Look at this MBD.
It says 55.
Okay,
So
so MED I made opposite. I made opposite. I should have said 55 to router 4. I said bigger is bad, no? If I
yes.
don't want wire router 4, I should put 55 here, isn't it? I made wrong. Where did I make wrong? I made wrong when I was applying it. I applied to the wrong guy. Okay, now I'll say neighbor 10.24.0.4. I'm making this road as bad road for these two networks. So I need to apply.
The road between 4 and
Hey,
5.
hold on. I'm doing in the wrong device.
Okay.
I'm doing in the wrong device. I should download it. Okay, clear, do clear. Now,
Star.
yeah, no problem. Now, I'll say neighbor 10 dot 40, 24 dot 0 dot 4 route map clear IPBGP star soft clear IPBGP star soft clear IPBGP stars. Okay, we are going to check it now. Let us go to router 4 to test. Show IPBGP.
Oops.
All right, now look at this. Wonderful, wonderful. For 111, it is not going straight to router 2. Why? MID is very
Because
big.
right.
Bigger is bad. For 11 also, it is not going via router 2. But for 111, it says I will go only via router 2. You got it? Let us test it
Yes.
now. For 11, it should not go from 4 to 2. It should go from 4 to 5
5.
and then 5 to 2. You see? And now for router, okay, 111 should go straight. Cool, no?
Right. Yep.
Okay. Now let's go back to the attribute. Let's go back to our attribute list. Okay. Now we are comfortable with this. And this also is over.
Yeah, because we saw that earlier on
What,
in the same
what about
class.
this one? Can you explain this attribute?
Prefer the path closest IBG. Prefer the path with the closest IBGP. What it is saying is that if you have, say, more than one autonomous system or more than one, no, if you have, no, because you're in the same IBGP is the closest one to the source that you're trying to reach. So if you have two routers, say two routers inside BGP 10,
Very nice.
and you have, say, you would sit at the shorter part or the
Yeah,
closest one to it.
you see, you're right. Router 1 has got two IBGP. One is router 2, another one is router 3. Isn't it?
Yes, sir.
Two IBGP. If there is tie in all the above attribute, there is no EBGP to prefer over IBGP, which means both may be IBGP or both may be EBGP. Now let us say both are
Right.
IBGP. If both are IBGP, whichever is closest, if R2 is closest, it will use R2. If R3 is closest, it will use R3. What do we mean by closest? Let's say here metric is 1. OSPF metric. Here you got Ethernet wire, and let's say metric is 10. Which is closest? This is closest.
1.
That is what here it means. Closest IGP. Closest IGP. Next is prefers the oldest route for EBGP path. Prefers the
That's
oldest.
easy that's easy. Meaning that if which one inform neighbors first?
Yeah, you see,
If you have 2.
if router 8 is not a tiebreaker, what does that mean? It means that both are not IBGP. Or both are not IBGP, which means both are EBGP. If both the neighbors are EBGP, it prefers the EBGP which advertised the route first. Not farming neighbor first, advertising the route first. Who gave the route first is the best neighbor. Next. There cannot be a tie in this 10th attribute. Mostly 99.99999% router 10 will be a tiebreaker. It prefers the neighbor whose router ID is lowest. Definitely one guy's router ID will be lower than the other one because router IDs are not duplicated.
Right.
Mostly router IDs are picked up from the loopback interface, and there are very less chance if you are using some private address in the loopback interface. There are very less chance that the router ID may be same. Very, very, very thin possibility. In the real world, according to me, it's not possible.
Right.
So even if it is if it is accident mistakenly done, BGP has got a solution. It is going to go to attribute number 11, preferring the path with the lowest neighbor IP address, which is always a tiebreaker. No way two neighbors can have same IP address in BGP because BGP is between the borders. There are public IP addresses involved. Any question on this attribute?
No, but we cannot replicate those from 7, 8, 9, and to 11. We can't replicate those really. We cannot do anything. We just have to know them.
We cannot manipulate those things.
Okay.
No.
Right.
Oh, yeah, you can manipulate this eighth one. You can go and change the OSPF cost.
Yes, you can. But we just have to know.
Other attributes are default.
Right.
As you said, cannot be manipulated. Okay. So this chapter brings us to the end of the theory portion of attribute. But the lab also we have covered. The next chapter, which I'm opening now, we have already covered with better examples. But in here also they have some example. Let us see that. Are you ready? We have done this something in a big level, but they are going to have some example, which let me cover it for you now. Here, how do you use route map in order to manipulate the path, BGP path? Here you see this example. This example is to show you that we have some policies in routing. This is just an example. They are trying to help us understand what is policy in routing. This is one server. This is another server. There are traffic going and coming. 60% of outgoing should be using the link between A and X. 20% should go using the link B and Y.
Yes, but outgoing.
That is exiting. For entering in, 10% via this link, 75% via this link. See, this is just to make us understand that we will have in our mind this type of load sharing. And now how to achieve this is what they are going to show you. But don't keep too much expectation in this chapter by seeing that 60%, 10%, 75%. Oh, percentage. Oh, let's do it. Wow, wonderful. BGP. No, it's not like that. You need to know which traffic, if I tune to go out like this, then it will be 60%. You need to know which traffic is consuming 60%. That you go and tune with some attribute. The 60, 10, 75 and all BGP cannot calculate for you. That is why I say don't have too big expectation. Don't misunderstand this example. This example is not only because of BGP. You can achieve this example with your homework. You also need to do some homework. You need to know which traffic will be 75% coming from outside so that I can do some tuning and make it to come this way. You need to do some study on your traffic time to time. You need to go sit analyze with some traffic analyzer and see during the peak hours what all traffic goes and how much percentage of traffic goes and comes in. This is known command. Do you know this command?
The local preference, yes. BGP.
This is global for all networks. For one or two networks, we used to write access list, route map, and then call it, which is the big way. This is small way. You don't have load sharing policy. You simply want traffic to come this way, not via that. Then you can go to this router where you want to prefer and give this command. Do you have any question on this
BGP
page?
default local preference value. And this is just local.
What?
This is just local to the autonomous system.
Yes. It is local to the autonomous system. Now, what is the difference between configuring local preference like this and configuring local preference like we did?
Not quite sure.
See, we did using access list and route map.
Yes.
Correct? And we said for 78, it should go out of router 2. For 87, it should go out of router 3. Definitely you need route map and access list because destinations, some you want to go via upper path, some you want to go via below path. But if you type this command, either all will go via upper path or all will go via bottom path.
Yes,
you understood?
That's what I was thinking.
Yeah. So this is rare case. See, this is not the command that will help you achieve this. This cannot be achieved through that command which you saw in the next page. In here, you are doing some load sharing manually. But this command is not going to allow load sharing. If packet is going via that way, they said by using this command, you can make it to go via this way. Okay. Now see this topology here. I'll ask you some question. Are you ready?
Yes, I am.
For router C, locate router
Yep,
C.
I see
It
it.
is in, okay. For router C, if I want to go to 192.168.28.1, which is the best exit?
Through router A.
Exit. If I want to go to 172.20.50.1, which is the best exit?
Router B.
Okay. You're saying to go to this, you exit via B. To go to this, exit via A. And to go to this one, which one will you use?
I use A. You
Okay,
can use either or, but I'll use A.
that's not a subnet. Okay. So to go here, you will go via A. It's one, two
Right,
hop. If you go this way, one, two, and
right.
three hop. So what you are seeing is the hop count. Okay, no problem. Now to go to this 170 to 30, which one will be your
I
preference?
go through router Y.
You'll go via router Y because it is only two
Right.
hop. So you will go via B. Okay, now because of that, what you said is correct. You see, 172.24. You will say you said you will go via B. B means 50.1. 24, 50.1. Correct,
Yes.
no? Next. 172.16. You said you will go via X, which is 28.1. 28.1. Correct, no?
Yes.
Next. 172.30. You said again you will go via 50.1, which is Y.
Yes.
Okay. So let us say 172.24 is 30 percentage. There it is. 30 percentage of traffic is to this. And 172, sorry, 172.24 is 30. Correct. 172.30 is 20.
Where's 24? Okay, okay, right. Okay, yes, I understand now. Yes. Okay.
This is
Mm-hmm.
30, that is
Mm-hmm.
24. And 172.16 is 10. Now tell me via B, via B, how much percentage of traffic is going out?
It's going out to where?
Huh?
It's going to where? I said 10 to 60, but going to how far? It is going. Is it going to Z or is it going to AS 6503?
But focus, please. You see, for this destination, you said you will go where this way.
Yes.
For this destination, you just said that. I'm asking the same thing. How much percentage that goes out in this topology? How much percentage is going out via B?
50.
Exactly. That's what I want. We already spoke about the
Okay.
destinations. Now, 50 percentage, isn't it?
Yes.
30 plus 20. Whereas in the upper path, how many
10.
percentage? Only 10. You see, BGP did not discover 10, 30, 20 and all. We need to have some study to know how much percentage for which destination so that you can do manual load sharing. Now, question is, if I want to share the load equally, what should I do? See here, it is 50 percentage down path, up path only 10 percentage. If I want to equally share this load, what is the equal number?
30.
30. So which one I should send via upper path so that I can have 30?
The 20.
Ah. So I need to write here a local preference or something and say, hey, if this matches 172.30.0.0 matches, local preference is 200, let's say 200. When you say 200 to X, so when X advertises, it will prefer X to go out. You agree or
Agree.
not? That's all. We have done these things already. You see, they are doing the same thing. Write an access list matching the 30. Yeah, match the 30. And then set high local preference. For the rest, don't do
Right.
anything. And then apply it to 28.1. Where is 28.1? This one.
Go back to that one moment. I don't see the access list that says 65. Oh yeah, it's up there. Yeah, I see it. Never mind. Never mind.
Easy, no?
Yes.
After doing that, if you see,
Wait one moment. You
now,
say in. You say in
of
because
course,
it's coming
in.
in.
When I am getting, which is coming in,
It's
170 to
coming in.
30 is advertised
In.
and coming
Yes.
in,
Yes. Yes.
isn't it?
Yes.
Hmm. So now if you see 170 to 13 is pointing towards the upper
Yes.
path, like 170 to 24 is down, 170 to 16 is up. So this is 10, this is 20, and this is 30. So 30 is via down path, and this 20 and 10 is
Upper.
via
Yes.
upper path.
Yes. Perfect.
Figures,
Yes.
of course.
It's good. That is good.
And MED we have done.
Right.
A very good on a good lab on MED with the route map. Here, if you want to globally configure MED, this is
And my thing. Why would you globally configure MED when you want to use it to?
for some people. For some people, they don't want to do load sharing. They want to prioritize another path which is not default,
Oh. Okay.
so they will use
Okay.
globally. All right, with the MED also we are doing similar lab here. Same like what we did in this lab here. Same like this. There is another example with MED. Same route map they are writing and setting MED instead of local. We did something better than this, so you can refer to our video better. That it will be better than this one.
Okay.
Okay. So this is after MED. So we did a thorough deep dive on attributes. Now, what is next? we are going to see is those things are not in this presentation. They are um, confederation. You're going to see
Confederations, okay.
confederation. Okay. Yeah, we're going to see confederation, and then confederation with route reflector because they are somehow connected. And then we will do a lab on with that. But confederation is no more seen in the real world. But we'll see. Just only once in a lifetime, nothing wrong to
Right.
know what it is in depth.